So guys, this is lecture 7, and in this lecture 7 I'm going to solve a similar equation. In lecture 6 you saw that we can separate the variables and we can solve the equation by considering the solution u is equal to x into y, two different functions, right? So in this question I have taken, the question is given in terms of z, like u they have replaced simply like a z. These two good questions I have taken. Now you can expect in GATE exam that your differential equation can be lengthy. For example, in aircraft structure also sometimes questions are lengthy. So it is expected every time that in GATE exam differential equation portion will be a lengthy portion, right? So suppose question is given like solve the following equation. I will just solve the following equation. What is the equation? Dou 2 z by dou t square minus 2 dou z by dou x plus dou y by dou z is equal to 0. By method of separation of variables we have to solve this problem. Okay, so you know the trick. What is the trick? Okay, this is the question given, but what is the trick? First of all you have to consider this z as your solution. Z is equal to x into y. In the bracket it is written x, bracket x means what? X is the function of x alone, capital Y is the function of small y alone, right? Okay, so this thing you already know, that yes, we have to consider that. I can zoom this also. Now you can see we know that x is the function of x and y is the function of y. This part we know, and we also know that the moment you assume z is equal to x into y, that time itself you have to find out the values of dou z by dou x, which will replace here, dou z by dou y, which will you will replace here, and dou 2z by dou x square. Okay, in previous example lecture 6 we found dou u by dou x, dou u by dou y. In same way dou z by dou x, dou z by, but here one thing is extra. What is extra? Dou 2z by dou x square. Nothing to worry. Dou z by dou x you will find out, right? Repeat again means one more time differentiation you do, right? So you can clearly see here, when you do dou z by dou x, that time you keep this y constant and you differentiate this x, so dou x by sorry, dx by dx. One more thing, why I am writing this d here and why I am writing dou here? Because I'll tell you. See, understand one very interesting, very good fact. I think in lecture 6 I didn't tell you. See, this z is the function of x also and y also. That's why whenever you will differentiate z, you will differentiate with dou, because it is a partial differentiation. Why? Because z is a function of two things, x also and y also. But whenever you will differentiate capital X, the capital X is not the function of x and y both. Capital X is the function of only x. That's why whenever you are differentiating capital X for small x, you are writing small dx by small dx, correct? And here also when you will write for y, then you will be writing small dy by small dy, correct? But again here when you are writing dou z by dou y, here you are writing dou. Why? Because here z is a function of x also and y also. I hope this part is correct. So you got this, and you differentiate once more, you got dou 2z by dou x square. Now these three values, whatever you have got, these three values you have to substitute where? In the main equation. Where is your main equation? This is your main equation which was given in the question itself. That is your main equation. Substitute them. After substituting, where will you work? After substituting, you have to work for variable separable. So you can see we have substituted here the values. After that, variable separable. So but problem is, with x term y is multiplied, with y term x is multiplied. So divide by xy throughout the equation so that x can be only with x, y can only with y. Okay, so what will you do? You will divide by capital XY. After division of capital XY, you have to separate the variables. So now you can see here, only x part I am keeping left side, y part right side. And like we did in lecture 6, u wala term, in same way here x one side, y one side, and because they both are equal, so consider they are equal to k also, right? Then what to do? Left term equate with k and solve separately. You can see here we have solved, and right term you equate with k and solve separately. So you can see here. Okay, now let's focus on the left side term. Left side term is this, equal to k. So now here, because now it is a simple ODE problem, ordinary differential equation problem, and in this ordinary differential equation problem you only have to find complementary function CF. That's all. That will be your solution of the left side. How? Very easy. So this x you see, we multiplied, it became kx this side, right? What is remaining inside? it is like a second order and first order. You take capital X common, it became d square minus 2d plus k, d square minus 2d minus k, right? Because this k also I took left side, so in right side 0 is remaining. That's why you don't have to find particular integral, only complementary function is sufficient. I hope you understood this part, because we have done ODE, then we are doing PD, right? This part is nothing for you. How did it came, how it came? This kx we took left side, and after that throughout from all the three terms we took x common, and then this equation became like this equation, and then we'll convert this into auxiliary equation, and then we'll find out the root, and because of root we'll be finding out our CF, complementary function, right? And here also we did the same thing. We sent y this side, and after sending y that side, we took our ky term this side, then this became like this. Then you take y common, and after taking y common from here to here, convert this into this kind of formation, and now this formation you have to convert into complementary auxiliary equation. So you can clearly see we are converting into auxiliary equation. So auxiliary equation is like, for the left side this is the equation, and for the right side this is the equation, correct? So now you can see here I'm getting two different roots, right? So whenever we have two different roots, m1 and m2, what is the solution of the complementary function? CF, which is CF is equal to e power I mean a1, you can consider a as a one constant, or directly you can write e power m1x, correct? Some, you know how to write complementary functions if you have two m1 m2, two different roots. So how will you write? See how I'm writing here. I'm writing here c1 e power whatever root is there, that is m1. Then I'm writing c2 e power whatever I got as m2, I'm writing here. This you know how do we write if you have two different roots. Same thing here. You got only one root. You can see here m is equal to minus k, only one root you have got. So if you have only one root, no problem. C3 e power whatever root is there with y, correct? Got it. So two roots we have got. Now for these two roots, we got our x value also and y value also. You can see here this everything is your x value, this everything is your y value. X value means not x value, function x is this much and function y is that much. Now that's all. You multiply both the functions because that is our assumption. How do we write solution? Z is equal to capital X into capital Y, both the values are there, multiply them, that became your final solution. Now if boundary conditions are given, like at x equal to 0 something was value of, at x equal to 0 y is equal to 0 something was z, if that kind of data is given, boundary value condition, or if some question is there time based, like in next example time based question, then we say initial value problems. So if those kind of boundary conditions or initial value problems are given, then we can find out value of c1 c2 c3, and we can find out our final. But because boundary conditions or initial value problems are not given, I mean initial values are not given, so we'll leave here itself. Now we'll go for our next question. So in next question again we can solve this question by using variable separable method. So what is your first approach? First approach is here. You consider your u value as a product of x and y, but here your question is in terms of time t, so you write t here. Okay, I am saying t because it is simple mathematical thing. Okay, in some other physics t can be temperature also, right? But here we are just dealing with the math, so t you just consider as a variable for the time. Okay, right now so what they have given, you can see this is the data given. In the last we will be using this to find out our constant value. This is like a boundary condition. Okay, so right now you forget this, you only focus on the solution, how to solve this. So to solve this, our first approach is consider the solution, assume the solution. Once you have assumed the solution, then you find out dou u by dou x and dou u by dou t, because here you have to substitute dou u by dou x, and here you have to substitute dou u by dou t, and here simply x into t. Okay, so there is one more way people solve this in the another way. What? Here itself you substitute u value, here is you substitute t value, and there you start differentiating. So you can, like you can see here, xt substituted here, xt substituted here, then expand this. Expand means differentiate this by keeping t constant, and differentiate this by keeping x constant. So this answer will come. Okay, you understood now. But problem is, in this answer t and x, they are together. I mean it's like mixed variable, we cannot separate. So for that, our original trick, what is the trick? Divide by xt. This is the trick, right? Divide by xt. I'll show you. You can see here, divide by xt. So you have to divide by xt so that all x term y term can be together. Go ahead. Then almost done. When you have divided by xt, then you can see here x term came together, y and t term came together, and that you consider as a constant c, like we in previous questions we have considered as k. Once this much is done, then you can take first part with the third part, means this part with this part, and wrote here, then multiply this x this side, done. And then you find out dx by capital dx by dx, and then you do this, done. Then take this left side and then take this x common, then d minus c will be there, then you find out d value, which is equal to c, or m minus c. M will be like one of the root. And same thing you do right side. In the right side, what will you do? You understood till here, we got the answer because we are equating this term with c, and then you multiply this t here, then ct by 2, then take all the everything left side, then from here you take t common, and after that it is visible. You can see here we wrote m minus c auxiliary equation is equal to 0. We got one root, so this time a is my constant and e power cx, and here you got m value as this bigger value. You can see half, you can see this value, I'm trying to say half c minus 1. This is your bigger value. Bigger means the m value. So for that you got this solution. Now that's all. Multiply both the solutions. You have to multiply both the solutions. When you will multiply capital X and small t as a solution, then you will be getting u value as your final value, a b cx half c minus. You can just shuffle whatever data you're getting, you'll be getting final this answer. U is equal to ab e power cx plus half c minus 1 into t. But given data is given to find out the constant. So they are saying at t is equal to 0, your u value is this much. It is given. It is given. If you see u bracket x comma 0 is equal to this much, answer is given. This much answer is given. Correct? It means for any x value but t is equal to 0, u becomes this answer. That is the meaning. So using this idea, substitute t is equal to 0 and substitute your t is equal to 0 and substitute your u value as 6 e power minus 3x, and you find out the value of ab. Ab came 6, and after comparison left and right side, you can see if you compare this power, then c is equal to minus 3. If you compare this coefficient, then ab is equal to 6. That's all. You got ab and c both. So substitute here ab at 6 and the c value inside as minus 3. That's all done. This became your required final solution, right? Then go for lecture 8. Now understand one thing. In lecture 7 what you have understood, and in lecture 6 what you have understood. You have understood how to use method of separation of variables to solve your differential equation. This much you have understood. Now in lecture 8 onwards, I will be explaining you if you have physical questions like wave in the string or heat flow or this kind of wave flow, so wave equations, Laplace equations. So there, with the given boundary conditions and initial value problems, how to reach till final solution. Okay, but those problems will be very lengthy, very lengthy problems. Usually in GATE Aerospace exam, if those kind of problems are coming, then anyway we are going to skip the problem because of lack of time. But suppose you are good in PDE but some other problems you are not able to solve and you are remaining with time, suppose half an hour is there, because these kind of problems when you are solving in GATE exam, it may take 7 to 10 minutes one problem in PDE. So this is GATE preparation. Strategy matters. Solution, only one question you are solving in half an hour, that is not a good thing. Strategy matters. So in you go to lecture 8 and upcoming lectures and you see whether you have, because pattern will be very simple. Pattern will be very simple in PDE. What to do, step by step, everything will be very simple. Okay, but you understand that, can you give this much time? Because when you will see the lecture, then you will solve the question by yourself one more time. And if you will check aerospace PYQs, they have asked PD problems. Then what is the length of those problems and what kind of problem, and to solve those problems, how much time you are taking, because time management is important. Then you decide that after going lecture 8 and upcoming lectures, then finally you decide that are you going to attempt these problems in GATE exam or not. But it should be in your mind that if you are having time, because sometimes what happens, sometimes it may happen that you got stuck at 29 marks, and somehow if you get 2 more marks you can qualify the GATE exam. So in that case, and you are having half an hour but you don't know which problem to solve, but PD you know. So in those kind of cases you can attempt PD problems. All right, so see you in the next lecture.